This is SpaceTime Series 25, Episode 4. Coming up on SpaceTime. A new study determines that antimatter falls down just like regular matter. A joint European and Russian mission to explore minerals on the moon. And the James Webb Space Telescope deploys its golden eye. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has confirmed that both matter and antimatter respond the same way to gravity. The research carried out at CERN, the European Organisation for Nuclear Research, would appear to finally answer that long-standing question of whether stuff made of antimatter would fall down the same way as stuff made of matter does. Of course, logic tells you that matter and antimatter should do the same thing. After all, they only differ in electrical charge. So on the subatomic scale, the antimatter counterpart to the positively charged proton is the negatively charged antiproton, and the antimatter counterpart to the negatively charged electron is the positively charged positron. As part of an experiment to measure, to an extremely precise degree, the exact charge-to-mass ratios of protons and antiprotons, the base collaboration at CERN found that matter and antimatter did respond to gravity in the same way. Matter and antimatter create some of the most intriguing problems in physics today. One of the great mysteries is baryon asymmetry. That is, despite the fact that they seem equivalent, the universe as we know it is made up almost entirely of matter, with very little antimatter. And that's puzzling, because equal amounts of matter and antimatter should have been created in the Big Bang 13.8 billion years ago. And the thing is, matter and antimatter annihilate each other when they come into contact. So, theoretically, the universe should have been destroyed in a blue gamma-ray flash almost immediately after it formed. Yet, here it is. So, that means there must be something different in the properties between matter and antimatter, other than charge, to explain why we exist. Now, as part of this quest, scientists have explored whether matter and antimatter interact the same way with gravity, or whether antimatter would experience gravity a little bit different compared to matter. The trouble is that would violate Einstein's weak equivalence principle, and as many physicists have found to their regret, messing with Einstein never really works. And now the base collaboration has confirmed Einstein's right. Within the strict boundaries of their experiment and its parameters, antimatter does in fact respond to gravity exactly the same way as matter does. The findings, reported in the journal Nature, actually came from a different experiment to the one they were trying to complete. It was examining the charge-to-mass ratios of protons and antiprotons, one of the most important measurements to determine if there's a key difference between the two. The work involved 18 months of research at CERN's Antimatter factory, the only one of its kind in the world. To make the measurements, physicists confined both antiprotons and negatively charged hydrogen ions, which they used as a proxy for protons, in a pinning trap. In this device, a particle follows a cyclical trajectory with a frequency close to the cyclotron frequency that scales with the trap's magnetic field strength and the particle's charge-to-mass ratio. By feeding antiprotons and negatively charged hydrogen ions into the trap one at a time, the authors were able to measure, under identical conditions, the cyclotron's frequencies of the two particle types, comparing their charge-to-mass ratios. The study's lead author, Stefan Ulmer, says the new results were essentially equivalent to a degree 4 times more precise than previous measurements. And the authors used these measurements to test a fundamental physics law known as the weak equivalence principle. Now, according to this principle, different bodies, but with the same gravitational field, should undergo the same acceleration in the absence of frictional forces. Because the base experiment was placed on the surface of the Earth, the proton and antiproton cyclotron frequency measurements were made in the gravitational field of the Earth, and so any difference between the gravitational interactions of protons and antiprotons would have resulted in a difference between the cyclotron frequencies. By sampling the gravitational field of the Earth as the planet orbited the Sun, researchers found that matter and antimatter responded to gravity in exactly the same way, at least up to a degree of 3 parts in 100. It means the gravitational acceleration of matter and antimatter is identical within 97% of the experienced acceleration. Ulmer says these sorts of measurements can lead to new physics. The 3% accuracy of the gravitational interaction obtained in this study is comparable to the accuracy goal of the gravitational interaction between matter and antimatter that other research groups plan to measure using free-falling antihydrogen atoms. Now, if the results from this study end up being different from those achieved by other groups, it could lead to the dawn of a completely new type of physics. And that would be exciting. This is SpaceTime. Still to come, the European Space Agency and Russia to join forces on a new mission to the Moon, and the James Webb Space Telescope deploys its golden eye. All that and more still to come on SpaceTime. The European Space Agency will include a drill and sample analysis package aboard a new Russian mission to the Moon's South Pole slated for launch in 2025. The mission, called Luna 27, will fly aboard a Russian Angara A5 heavy-lift rocket from the Vostochny Cosmodrome in far eastern Russia. The Roscosmos-led mission will prospect for minerals in a range of volatiles, including nitrogen, water ice, carbon dioxide, ammonia, hydrogen, methane and sulfur dioxide. It'll be looking in permanently shadowed areas of the Moon. The lander will have 15 science instruments to analyse the regolith, plasma in the atmosphere, or at least exosphere, as well as dust and seismic activity. Now, Europe's contribution, known as the Prospect Package, will include a percussion drill designed to go down up to 2 metres. There's a sample handling system called Proceed, which will collect the cemented ice samples and then deposit them into a miniaturised onboard sample analysis laboratory called ProSpar. Precise measurements will help unearth secrets of the Moon's history and also indicate whether future explorers could use lunar resources on their missions to help them set up a lunar base. The lunar South Pole region is of great interest to scientists and explorers. That's because the low angle of the Sun over the horizon leads to areas of partial or even complete shadow. These shadowed areas and permanently dark crater floors, where sunlight never reaches, are believed to hide water ice deposits and other frozen substances that could be analysed to better understand the natural processes that form them. They could also be used to produce resources such as oxygen, drinking water and even rocket propellant. As well as Prospect, the European Space Agency will also add a new automated landing system for the mission as well. This report from ESA TV.
Prospect is really one of the stepping stones between the early robotic phase that we're seeing now and the future where a human activity on the lunar surface may make use of lunar resources in order to have a sustainable presence on the lunar surface.
If you land anywhere on the Moon, you can extract oxygen. If you land at the poles, it may be a little easier because you can get to water and other volatiles that might be there. And so volatiles are things that can be very mobile, so they can sublime into a vacuum. But obviously they're of interest to us because we can breathe and drink them. So water ice, for example, is thought to be abundant at the lunar polar regions.
So Prospect is a combination of a drilling and sample analysis package. The drill will drill down to depths of up to 1 meter below the surface. So it's not the first time that drilling has been employed on the Moon, but it's the first time that it will have been done in these polar regions.
We are now going to test the first model that has been built. We are going to test it, so to see if the drill works, all the instruments and mechanism works perfectly, and we are going to perform some drilling tests and sampling coring and sample delivery to the sampling system.
We collect 2 samples while after drilling. One sample is collected using a dedicated mechanism that allows to collect the sample and close the chamber after the collection. So we keep the sample within a dedicated chamber for the Russian sample. And then we perform the same operation with the for the European instruments.
We don't know exactly how much water ice we might find. So in the tests, we're doing some that are dry, which have no water ice in. For others, we inject a little bit of water, and then we range up to saturated regolith, which has a very high fraction of water in the subsurface.
One of the tests on which I am more curious of is the test with the 6% of water content. So we will weight the percentage of the water, we will mix like an ice cream making, and then we will froze the simulant down to the minus 150 degrees C.
Under lunar vacuum, when you have an icy material, as soon as you expose it to higher temperatures, it immediately sublimates into the vacuum. So it doesn't go through a melting point, it just disappears into a gaseous form and you've lost your sample.
The point is, during the drilling, you are producing heat due to the mechanical attrition of the drill tip and the lunar soil. This is unavoidable. So what we are doing is to balance the power injected, controlling the rotation of the coring and the rotation and the speed of the drill in order not to go too fast and so not to produce too much heat.
The PROSPA is the European instrument that is part of Prospect. It will be based on miniaturized oven, which will receive the samples from the drill. It will seal the ovens and it will perform the measurement of the contents. PROSPA contains a small carousel and with a disc on which 25 ovens are mounted. We started many years ago in studying coring and drilling systems. Actually, the first drill that went to space was the Rosetta drill for the Rosetta mission.
Prospect has a great heritage from Rosetta, from the conceptual point of view, because there is the task of drill, there is the task of collect the sample and to deliver the sample to the instrument, and the in situ observation of the material.
Our objective is not just to fly the single Prospect payload, but also to put Europe in a position where we can also work on the topic of lunar resources in the context of other payloads, and really to develop the expertise of the community in this area, which is already happening today.
From an exploration point of view, it has the potential to change the moon from a thing that we see in the sky to a place that we can go. By understanding how we can use the resources that are there, it then opens the door for other people to potentially exploit those resources.
We really hope to go to the moon very soon, and a few years from now, so this is really exciting and it has just begun.
My hope is that with missions like Prospect and the missions we're seeing coming up, that this is actually opening a new door to lunar exploration, which might actually see a bigger participation of the public, and perhaps even see my children or grandchildren participating in that exploration and visiting or even living or working on the lunar surface.
And in that report from ESA TV, we heard from Prospect Project Manager Richard Fizachary, ESA Prospect Project Scientist Elliot Sefton-Nash, Prospect Project Manager for Leonardo, Andrea Zamboni, Proseed System Engineer for Leonardo, Christian Panzer, Project Engineering Manager for Leonardo, Andrea Rusconi, and Software Prospect Engineer with Leonardo, Patricia Bologna. This is SpaceTime. Still to come. The James Webb Space Telescope continues the complicated process of unfurling and reconfiguring itself for operations, and new measurements on the asteroid Apophis, which will make a close encounter with the Earth in 2029. All that and more still to come on SpaceTime. NASA's James Webb Space Telescope has successfully unfurled its major components, marking a key milestone in the long and complicated process of reconfiguring itself for operations. The $10 billion successor to the Hubble Space Telescope was launched aboard an Ariane 5 rocket from the European Space Agency's Kourou Space Centre in French Guiana into a highly elliptical orbit that'll see it positioned 1.5 million kilometres away in what's known as Lagrangian L2 position, a sort of gravitational well that will always keep James Webb on the opposite side of the Earth from the Sun. But in order to reach space in the first place, the giant 21 by 14 metre telescope first had to be folded up origami style so it would fit in the payload fairings of the launch vehicle. It'll take about a month to reach its eventual perch, some 4 times further away than the Moon, and another 5 months to begin science operations. That's assuming this complicated process of unfurling the giant observatory continues to proceed as planned, and there's a lot that could still go wrong. The origami-like process of setting the telescope up in orbit takes several weeks, with hundreds of release mechanisms needing to operate exactly as planned for the 7-ton observatory to expand to its full operational size. Its solar array and 5-layered sun shield were the first to unfurl and lock into place. That all went smoothly. They were followed by the secondary mirror and the aft deployable instrument radiator, a specialised assembly necessary for the Webb science instruments to reach their stable operating temperatures. Then came the golden primary mirror, composed of 12 octagonal segments which were folded into 3 sections for transport. Over the weekend, the 2 wing sections successfully opened out and latched into position. This was a major milestone in the telescope reconfiguring itself for operations.
We have started our deployment into the deployed hard stops, and our current looks really good, nice and low.
Mount copy.
That was another of our deployment engineers confirming that everything looks good with our mission operations manager. It's going to be momentous when it finally comes into position.
The first wing was successfully deployed yesterday, and now this is the final part, the primary mirror being put in place. Give us a sense of the scale. These mirror segments. I mean, I had the honor of watching this being built. A lot of it at Goddard. How big across, for example, is one of those hexagons?
They're about 1.5 meters across from tip to tip. The hexagons are quite large. It's amazing to actually be in the clean room and look up to see the whole mirror assembled, towering above you. There's no amount of seeing it on photos that kind of gives you the sense of actually standing next to it in our clean room when it was assembled. Once it's fully into position here, the final shape that our primary mirror is going to be called a tricontagon. It's about a polygon.
The step lead on ops are about 3/4 of the way through the deployment, and everything still looks really good.
The mirror itself will be concave. Also, as the mirror comes forward, there's a thing called the bat wing, and it's a shade that falls down behind the mirror to help shade any light or heat that might be coming up through the hole in the sunshade from keeping any of the backside of the telescope warm. There's one on each side that comes down passively as the motor moves this forward.
This is step lead on ops. We have reached the end of deployment, and we are preloading into the latch pads.
All right.
You see people clapping, yes? Wonderful.
Everyone's up on their feet and clapping.
The primary mirror is successfully deployed. This is a first. We have made a space observatory the mirror was so large that it had to be folded up to fit inside the rocket.
Hey, OC, at this time we're ready to continue with 693.046. Enable activate SCS 256. That command line looks good. You're go to execute.
Copy that. Go ahead and execute. Execute.
I think you can hear the relief in our deployment ops.
And you're going to enable activate.
Copy, go to enable.
I have to say, I just feel this kind of glow, in my chest right now. Just seeing that mirror all deployed, all together. The size of a mirror allows us to collect more light from fainter objects, and in a lot of cases that means farther away objects that light took many billions of years to travel to us. A chance to see the universe as it was, perhaps only a couple 100 million years after the start, after the Big Bang. The sensitivity of this mirror will allow that, and the size of the mirror also gives us a clearer, higher resolution, able to see more detail in space than ever before. So this was something that absolutely had to happen. We had to unfold this mirror. The secondary focusing mirror had to come out, and then a little bit more than a week ago, the amazing sun shield. We are live at the Space Telescope Science Institute, and we have successfully unfolded the last part of the primary mirror. After this, there are still more commissioning acts to come, very important ones, for example, focusing.
Because of its distance from Earth, if anything does go wrong during this process, NASA won't be able to send astronauts out to repair it as they did with Hubble following its launch in the Space Shuttle Discovery back in 1990. The hundreds of components have repeatedly been tested on the ground and in simulated space conditions to ensure they work exactly as planned, but there are always concerns following the rigours of launch. Once operational, James Webb's 6.5-metre mirror will peer back through space-time into some of the earliest days of the universe, back to a time more than 13.4 billion years ago, when some of the very first stars in the universe began to shine. Now, unlike its predecessor Hubble, which viewed the universe mostly in visible light, only dipping very slightly into the infrared on one side and the ultraviolet on the other, James Webb will focus on the near-infrared part of the spectrum. That will allow it to see the ultraviolet light from the very first stars, which has been stretched into the infrared by the physical expansion of the universe itself. As well as studying the first stars and galaxies, James Webb will also explore planets orbiting distant stars, searching for signs of life in their atmospheric composition. This telescope will change science's understanding of the universe, just as Hubble did before it. It'll answer questions we haven't even begun to ask yet, and of course it'll raise lots of new questions for future experiments and determination. This is SpaceTime. Still to come, the latest measurements on what was once considered the Armageddon asteroid Apophis. And later in the science report, as we continue ploughing through the holiday season, a new study has shown that for the most part, hangover cures simply don't work. All that and more still to come on SpaceTime. A new forecast by the Russian Emergencies Ministry warns that the Asteroid Apophis' close encounter with the Earth in 2029 will see the mountain-sized space rock skim over the planet's surface at an altitude of 35,800 kilometres, closer than the orbits of many geostationary satellites, and some 2,000 kilometres nearer than previous estimates. The 380-metre-wide asteroid 99942 Apophis has long been the poster child for hazardous near-Earth asteroids. By the way, that name Apophis, well, it was the name of the ancient Greek god of chaos. NASA once classified Apophis as a potential Earth impactor. It was until more detailed observations of its orbit ruled that out. But on April the 13th, 2029, Apophis will hurtle past the Earth at some 7.42 kilometres per hour. It won't hit us, but it will come awfully close. In fact, during the 2029 close encounter, Apophis will be clearly visible to people on the ground in Europe, Africa and Western Asia without the need of a telescope or binoculars. It will be the closest asteroid of its size in recorded history. Astronomers estimate it should be as bright as magnitude 3.1 and visible with the unaided eye from rural and darker suburban areas and clearly visible with binoculars from most locations. Calculations suggest that were Apophis to directly impact the Earth, it will hit with a force of 1,717 megatons of TNT. By comparison, the impacts which created Meteor Crater in Arizona 50,000 years ago and the Tunguska event in Siberia in 1908 are estimated to have only been between 3 and 10 megatons. The biggest hydrogen bomb ever exploded, the Soviet Union's Tsar bomber, was around 57 megatons, and the 1883 eruption of Krakatoa in what is now Indonesia was the equivalent of roughly 200 megatons. So any way you look at it, an Apophis impact would be devastating. While not a planet killer, certainly enough to wipe out a continent. Of course, the exact effects of any impact would vary based on the asteroid's composition, the location of ground zero, and the actual angle of collision. Still, it's fair to say that any impact would decimate an area of thousands of square kilometres, creating an impact crater more than 5 kilometres wide and triggering major tsunami, seismic activity and climate-changing debris clouds. Scientists say the earthquake caused by such an impact within a radius of, say, 10 kilometres from ground zero could be as much as 6.5 on the open-ended Richter scale, with wind speeds reaching at least 790 metres per second. The European Space Agency's Centre for Near-Earth Objects says that 2021 saw more than 3,000 near-Earth asteroids added to the list in a single year for the first time. The update means there are now some 27,764 asteroids and 117 comets classified as near-Earth objects. That is, celestial objects whose orbital path takes them close to or crosses Earth's orbit around the Sun. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found that microplastics detected in southern France could have been transported for more than 4,500 kilometres from their source, traversing entire continents and oceans. The findings, reported in the journal Nature Communications, are based on microplastic pollution samples collected from the atmosphere of the Pyrenees in southern France. Computer modelling showed that these particles travelled an average of 4,550 kilometres over the previous week from their points of origin in the Americas and Africa. The findings show how microplastic pollution spreads globally, even reaching remote regions that don't use much plastic. Paleontologists have identified a new species of long-necked sauropod dinosaur in China. Sauropods are those dinosaurs with elephant-like bodies and legs, a really long neck and small head at one end and a really long tail at the other, sort of like Fred Flintstone's pet Dino. The new dinosaur, named Romulopithecus turbinensis, roamed the Earth during the late Jurassic epoch, approximately 155 million years ago. The giant herbivore was around 25 metres or 86 feet long. The findings, reported in the journal Vertebrate Paleontology, claim it was a member of a group of dinosaurs which had spread across Asia and Africa during the Jurassic and early Cretaceous. These dinosaurs added extra vertebrae in their necks to elongate them, and in addition to this, they made each individual neck vertebra longer. Scientists don't know why they did this, but they presume it was either a feeding adaptation or for sexual selection. A new study has shown that for the most part, hangover cures don't work. The findings, reported in the journal Addiction, assessed 21 placebo-controlled randomised trials looking at different hangover cures. These included things like clove extract, red ginseng, curcumin, prickly pear, Duplac Pro AP4 probiotics, artichoke extract, rapid recovery, loxaprofen, herb fruit extract, Korean pear juice, extract of clove buds, morning fit, which is made from dried yeast and thiamine nitrate, pyridoxine hydrochloride and riboflavin, a polysaccharide extract, and numerous other proposed hangover cures. The systematic review was carried out by scientists from King's College London, but it found only a very low level of evidence sustaining any of these hangover cure claims. Now, the studies did have their problems. Of the 21 included studies, 8 were conducted exclusively with male participants. They were generally limited in their reporting of the nature and timing of the alcohol challenge that was used to assess the hangover cures. And there were considerable differences in the type of alcohol given and whether or not it was consumed alongside food. Common painkillers such as paracetamol and aspirin were not evaluated in this trial. Now, according to the researchers, future studies will need to be far more rigorous in their methods. For example, they need to use a validated scaling system to assess hangover symptoms. The funny thing about being a kid is that no matter who you are, what your cultural background is, or where you come from, you'll always grow up hearing about ghost stories and the paranormal. From fairy tales to science fiction and horror movies, there's clearly something about the paranormal which triggers the imagination of people. And once you place a religious interpretation on it, it becomes a way to connect with the past, ask fundamental questions about the nature of humanity, and even postulate what happens after death. And anything that ingrained into the human psyche must have been an important part in the development and evolution of Homo sapiens. Most cases of the paranormal come from a misinterpretation of personal experiences, the human brain trying to make sense out of something it really doesn't understand. But Tim Mendham from Australian Skeptics points out there is another aspect to all this worth considering.
Who doesn't love the paranormal? Because it depends on which area you're looking at. It's largely fun. I mean, half the time, you're talking about ghosts or you're talking about UFOs and that sort of thing. From a skeptical point of view, that's largely the fun end of the scale. That's where we all like to play sometimes. And it's good, but the thing is, of course, it's not necessarily true. It's like a lot of fun things.
It's not necessarily true.
Yeah, no. Well, it ain't necessarily so. You're a skeptic. You can't say absolutely that these things are not true.
All right, good point.
But you can be pretty sure, right? You can be pretty sure.
I'm 99.9 repeated % sure they're not true.
But I mean, how do you explain people enjoying the paranormal? Because it is fun. But when you get this half-fun thing, people go beyond the fun and they start trying to get scientific about it. Funny, that skeptics, would you believe?
Yeah, my friend George believes, he totally believes in ghosts, totally believes in tarot cards and all that sort of thing. Absolutely certain that this stuff's all real. And you cannot convince him otherwise. It's just that I'm not bright enough to know and understand what he's on about. That's the problem.
That's right, yeah, and you're keeping a closed mind.
Yes.
As opposed to a open mind with equal an empty head.
Hole in the head, yeah.
Well, yeah, anything that passes drops in. But basically, I mean, there's all these people now trying to turn and do a scientific analysis of it, etc. The paranormal investigators who set up little groups who go out and check out ghost hauntings and that sort of thing. For some reason, they always wear camouflage outfits at night, which strikes me as, jungle.
Yeah, don't the ghosts sleep at night like we do?
Well, I don't know. I don't know why it's always at night, but of course, always at night it's dark and it's more effectively scary, right? Surely a ghost should be there any time. They don't sleep, as you say. But anyway, and these.
So a ghost is naked? It's an obvious question. Do their clothes become ghosts too when they die? I guess is what I'm asking.
Are you asking? Why do they wear sheep?
Well, that's another one.
With little holes in the eye, for the eyes. I don't know. No one knows. This is one of the problem things about ghosts. Do they look like when they died, which would be pretty scary if someone died in a horrible car accident? Or
I've seen the movie Beetlejuice. I know what goes on.
American Werewolf in London is pretty good, actually.
Oh, is that right?
That's got people who've died and they look like how they died. But unless you sort of believe in Titanic and you come back as a younger person, a younger you, and how you used to look looking gorgeous like Kate Winslet. But it's a dilemma, mate. You just, do they wear clothes? Do they wear the clothes they died in? Do they haunt the place they died in? I know of ghosts, stories of ghosts who supposedly haunt buildings they never occupied. In fact, ghosts who haunt buildings that never were there when they died. So, there's a few problems with this. The scientific, in quotes, paranormal investigators go into a haunted house with all their little machines and things that go beep, and then they get very critical of the TV shows, which they say are full of BS, that they don't really sort of do it very well, and so on and so on. But really, they're struggling. They still don't come up with any firm evidence either. Anyway, whether they're using things that go beep or whether they're just going in there to be scared.
It always comes down to something they feel, doesn't it, in the end?
They feel a change of temperature, or they feel, and I've seen so many ghost videos and things of, say, this is absolute proof. You say, no, it's not, it's rubbish. It's either obviously faked or it's just so vague you can't see anything. Same for the voices you hear. You can only hear the words they're supposedly saying if you've already been told the words they're supposedly say. I always say to ghost hunters and things, or people who claim there's a ghost, they've got a recording. Play it to someone, but don't tell them what it is or what's being said at all. Don't even say it's a ghost. Just play it and see if they come up with the same results. 99 times out of 100 they won't. But, technology, no technology, sensitivities, no sensitivities. There is still, unfortunately, no evidence and no reason to believe, and anything put forward is dubious. Energies and that sort of thing is dubious. Unfortunately, ghosts are fun, but treat them as fun.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.